Tossing a coin. When one coin is tossed, the possible outcome is head or tail. The sample space is equal to h, t, and n of s is equal to 2. Let us see what happens when two coins are tossed. The sample space is obtained as head, 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 tail, tail, head, tail, tail, and hence the sample space can be written as in the set head, 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 tail, tail, head, and tail, tail. Therefore, the n of s is 4. Now let us see what happens when 3 coins are tossed simultaneously. The sample space is explained in this manner. Head, head, and head. Head, head, and tail. Head, tail, and head. Head, tail, and tail. Tail, head, head. Tail, head, tail. Tail, tail, head. Tail, tail, tail. So, the number of elements in the sample space we get as 8. A coin is tossed once. What is the probability of getting a head? When the coin is tossed once, the sample space will be h and t, and n of s, that is the number of element in the sample space, is 2. The event to be considered is getting a head. So we have in the sample space one head. Therefore, n of e is equal to 1. P of e is equal to n of e by n of s. That is equal to 1 by 2. And hence, when a coin is tossed once, the probability of getting a head is 1 by 2. Two coins are tossed simultaneously. What is the probability of getting at least one head? Before solving the given sum, let us learn how to write the sample space when more than one coin is tossed using tree diagram. For the first coin, we write head and tail. For the second coin, we write head, tail in this manner. Now, let us see what the outcome it may be. The first outcome it may be head and head. The second outcome it may be head and tail. The third outcome it may be tail and head. And the fourth outcome it may be tail and tail. And hence, in this manner, we can get the sample space when more than one coin is tossed. Let us proceed to solve the given sum. When two coins are tossed simultaneously, the sample space is equal to head, 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 tail, tail, head, tail, tail. Therefore, n of s is equal to 4. Now we have to find the probability of getting at least one head. Here the key word is at least one head. It means it is one and more than one. Therefore, the event to be considered is getting at least one head. As mentioned earlier, whenever we are getting at least one head, we have to consider one and more than one. Therefore, the set E is head and head, head and tail, tail and head. When you go to the fourth one, we are not having the head, we got only the tail and tail, hence that should not be considered. N of E is equal to 3. P of E is equal to N of E by N of S, that is equal to 3 by 4.